What does electric charge actually look like if you could see it? Instead of just memorizing plus and minus signs and a rule about attraction and repulsion. In the energy filament theory, the universe is a stretchy sea of energy that can be tightened and wrinkled. Every charged particle is a tiny loop of filament that squeezes that sea in a very specific way. Start with charge itself. You already know the slogan, like charges repel, opposite charges attract. In a textbook, it is just a rule with arrows on a diagram. Here is a picture instead. Imagine an electron not as a point, but as a little loop of filaments pulled tight in the energy sea. If the loop's inner side is wounded slightly tighter than its outer side, it tugs the sea gently towards its center, like pressing your fingertips into a tight leather sofa and seeing the leather sink inward, dragging the material around it towards the dent. That overall tendency for the sea to gather inward is what negative charge looks like in this language. Now imagine a loop whose outer side is wounded tighter than its inner side. It is like pushing up from underneath the sofa so the surface domes outward in rings. Or like a water ring that bulges as it expands. The sea is pushed outward instead of pulled inward. That outward shove is the real shape of positive charge. So charge stops being a symbol and becomes two static fabric states, inward gathering versus outward swelling. With that in mind, like charges repelling is no longer mysterious. Picture two water jets shooting straight at each other. When the streams meet, they spray sideways. Or picture two hands shoving up on the same patch of sofa from below. The leather between them is squeezed with nowhere to go and both hands end up pushed apart. When two negative charges get close, both loops are trying to pull the same patch of sea towards themselves. Their inward tugs collide in the middle, creating a choking point that the fabric cannot satisfy for both at once. So the easiest way to relieve the strain is to let the loops slide away from each other. When two positive charges get close, both are pumping the sea outward into the gap between them. Like two people blowing air into the same balloon from opposite sides. The middle is overstuffed as though the system relaxes by pushing the sources apart. That is, like repels as a fabric trying to avoid impossible crowding. Opposite charges attracting is the flip side. One loop is pulling inward, the other is pushing outward. Like a drain and a faucet connected by a pipe. The outward flow from the positive side feeds straight into the inward pull of the negative side. So the sea does not need to fight itself in the middle. The directions line up into one smooth channel. Sliding the loops closer together makes that shared channel even shorter and easier. So the whole system lowers its tension by bringing them together. Opposites attract is just the two patterns finding a path of least resistance where outward push and inward pull join into one flow. Now zoom out and talk about the electric field. If you sit on the same spot of a leather sofa day after day, you eventually leave permanent creases and folds. A charged loop that has been pulling inward or pushing outward for a long time does the same thing to the energy sea. A negative loop, always tugging inward, carves ring after ring of inward pointing texture around itself. A positive loop, always swelling outward, carves ring after ring of outward pointing texture. These directional surface lines in the sea are the electric field. They are not imaginary arrows we sketch on paper. They are real, fine grooves and ridges in how the fabric is stretched. Finally, electric force is just what happens when another charged loop walks into that textured region. From its point of view, the sea under its feet is not characterless. Every direction has a different combination of smoothness and strain built into the existing creases. The particle simply slides along the route that fights the fabric the least. If a positive charge walks into the inward pointing texture of a negative field, its own outward pushing pattern can mesh with those inward creases, like swimming with the current instead of against it. So the easiest direction is towards the negative center and we say it is attracted. If that same positive charge enters the outward pointing texture of another positive field, its own push fights the local push, like trying to swim upstream in a strong flow. So every step toward the center feels harder and the easiest path is to slide away. We call that repulsion. Negative charges in the field behave with the roles reversed. But by the same logic, put all of this together and charge and electric force stop being magic rules. Charge tells you whether a loop makes the sea gather inward or swell outward. Long term, that pulling and pushing carves directional textures in the sea. Those textures are the electric field. When a new charged particle arrives, it is not yanked by a ghostly hand. It is just choosing the smoothest path down those tiny slopes in the fabric. Tap follow, share it on New Physics, Clear Universe.